In this class, we will discuss some problems on equilibrium of concurrent force system. Last class, I had explained the concept of equilibrium along with the conditions of equilibrium. So, in the case of a concurrent force system, the conditions of equilibrium are only two. So, the conditions are sigma fx 0 and sigma fy 0. So, these are the two equations of equilibrium. By using these two equations, we can analyze problems on equilibrium of bodies. Now, in the first example here, you can see that there is a sphere here. The weight of the sphere is 100 Newton. The sphere is connected to the wall with a string. So, this is the string, OA is the string, and it has a contact point to the wall at B. Sphere has contact point at B. So, this is the wall, this is the string, and this is the sphere. So, the purpose of providing string is to carry tension force. So, always the force in a string will be a tension force. It can be a cable or a string. So, tension force will be there in this string, and there will be a reaction at this contact point. So, I have told that to withstand the forces or actions, they should develop reactions. So that reaction will be developed at B, where the sphere is touching this wall. Now we have to find the tension in the string. So I will take this tension as P, and the reaction at B. So this reaction will be acting normal to the wall like this. So it will be attached to this wall. So this reaction I will take as R. So R is the reaction from the wall, and T is the tension in the string. Now using the equations of equilibrium or Lami's theorem, we can find out the values of T and R. So the first thing is we have to use these two equilibrium equations because all the forces are meeting at this point O. So if you write the free body diagram of the sphere, so free body diagram is a diagram which is written by removing all the contact surfaces and replacing them by the respective reactions, including the weight. So what are the forces acting on the sphere, and what is the reaction that is going to develop, and weight of the sphere, all this will come into picture when you are writing the free body diagram, FBD of sphere. So whenever you are analyzing any problem in mechanics, so we have to write the free body diagram, and we have to show the forces and reactions and the weight of that particular object, and then we have to use the equations of equilibrium. So here the forces acting on the sphere are, there is a tension force here. Tension force always is indicated by an arrow away from the center of gravity here, away from the point of contact. So here the string is like this. So it is connected to the wall. So therefore, there will be, when the weight of the sphere will be acting downwards. So weight will be acting downwards, which is given as 100 Newton. So naturally, the tendency of the force in the string is to pull the object. So it will be acting like this, away from the point, that is why it is called as tension. So always tension force is designated by showing the arrow away from the point, and compression force is designated by showing the arrow towards the point. So towards the point. Now here this is the weight, this is the tension, and reaction will be at this contact point is B. So normal reaction will be there here. R is the reaction, tension, T is the tension, T in the string, R is the reaction. Now all these three forces, if we extend this, all these three forces are meeting at this common point O. So that is why this is a case of concurrent force system. Now we have to apply this these two equations of equilibrium, sigma fx 0, sigma fy 0 for this diagram, taking this global horizontal as x-axis, global vertical axis y-axis. Now we can resolve the forces. So to resolve the force, I need this angle. So here he has given this angle as 15 degree. When this is 15 degree, this becomes 75 degree. So 90 minus 15, that is 75 degree. Now if you resolve the forces, this T force if you resolve, so this T force if you resolve, this angle is 75 now. So if you resolve the force, T cos 75 will be like this. T sin 75 will be like this. So these two are the components of the force T. So T cos 75, T sin 75. Then this R you need not resolve because it is horizontal. W you need not resolve because it is vertical. So now let us apply these two equations of equilibrium. The first equation is sigma Fx 0. I will take forces acting towards right as positive. So the algebraic sum of the forces in x direction should be 0 and the algebraic sum of the forces in y direction should be 0 to for the equilibrium of the sphere. Now if I apply this, R is acting towards right, so R is positive and this T cos 75 is negative minus T cos 75 is equal to 0. Only two forces are there. Next, taking the second condition, sigma F1 is equal to 0. In this case, I will take upward force is acting positive, downward force is negative. So this force is upwards, T sin 75 is positive, whereas this 100 Newton is acting downwards, so minus 100 is equal to 0. Now we have to solve these two equations to get the values of R and T. So from the second equation, we can take T as 100 divided by sin 75 degree. And if you simplify this, 100 divided by sin 75, we are going to get the value of the tension in the string. So 100 divided by sin 75 will be equal to 103.53. 103.53 Newton, because weight is in Newton, this tension also will be in Newton. So T is the tension in the string which we have at 103.53. Then substituting this value of T in the equation, in the first equation, so substituting for T in equation 1, we can get the value of R. So from equation 1, R is equal to T cos 75, T cos 75, that is 103.53 into cos 75. So the value of this will be into cos 75. This value will be 26.8 Newton. 26.8 Newton. So this is the normal reaction at the wall. So of course the wall is a smooth wall. Only normal reaction will be there. So you will not be having any frictional force. If it is a rough surface, then we will be having frictional force also, which comes into effect in the case of dynamics problems. So when the body is moving. Now here, so this is how we have to solve a problem of equilibrium of concurrent force system. Now one more problem I will take, wherein an object is given an inclined plane. Second problem, an inclined plane, an object is resting like this. So here the angle of inclination, he has given 30 degrees and he has given a block here. So this angle he has given 30 degrees, angle of inclination of the plane with respect to horizontal. A force P is applied on this object. The tendency of the block is to slide down because of gravity. It tries to move downwards. To avoid that movement of the block, let us apply a force P in the horizontal direction, and also the weight of the block he has given 1500 Newton. So weight of the block W he has given 1500 Newton. So P is an unknown force. So this P actually passes through the center of gravity of the block. He has given like this. This is the block. Now the question here is, so we have to find out the value of the reaction of this inclined plane on this block. So like this. This is the reaction, because this is the contact point, contact surface. So the reaction now at right angles reactions will develop, and also we have to find out this horizontal force P which is applied to resist the movement of that block over the inclined plane. Now P and R are unknowns here. W he has given, W is the weight of the block. Now to analyze this problem, of course we have to write down the free body diagram of this block. So I will write the FBD of block. You know how to write the free body diagram of block. So remove all the contact surfaces, replace them by the respective reactions, and write down the forces acting on the block and also weight of the block. So here in this case, So the block is like this. Weight of the block always acts vertically downwards irrespective of its position. 1500 Newton acts downwards. P he has given, of course, let me take this as the center of gravity of the block. P is acting like this, it is passing through G only, and this R will be acting like this. This also passes through the center of gravity like this. So now W is one force, P is another force, reaction is another force. Now only thing is we have to resolve this into horizontal and vertical components, and then we have to solve the problem. So in such a problem, for problems on inclined plane, what we can do here is we can take the parallel to the plane as x-axis. That means I can take like this. This I can take it as x-axis, and perpendicular to the plane I can take it as y-axis. Instead of taking horizontal and vertical, I can take along the plane. So this is the plane. Along the plane we can take x-axis. Perpendicular to the plane we can take it as y-axis like this. And we can resolve along those two mutually perpendicular directions. So what are the forces which we have to resolve now? So now this is 30 degree, therefore this is also 30 degree. Now we have to, what the thing is, we have to resolve this W, this R, as well as this P along this and this direction. So that is very important. Once you know how to resolve them in those three mutually perpendicular directions, then we can easily write down the equations. Now here, what happens here is, of course this P is horizontal and this W is vertical. So this R we have to resolve. Now okay, you can do like this also, or by taking global x and y axis also you can do it. Anyway, let us try by both the things. Now I have first one by one I will take. This is P. So all of you please be careful here. P, this P is unknown. This is making an angle of 30 degrees with the plane. Now I want to resolve this into two components. One component will be like this, another component will be like this. So I have to resolve them along x and y direction. These are the x and y directions. If we resolve this P along x and y, it will come like this. This is P cos 30 and this is P sin 30. Because 30 degrees is the angle adjacent to this side. So this is composition as a resolution. Next I will take the second force W. W is acting like this, 1500 Newton. So this step is very important. Once you resolve them, then you can easily apply the equations of equilibrium. Now the plane is like this. You can see that this is 30 degrees. So if you resolve this into two components, along x-axis this is the component, along y-axis this is the component. So you have to resolve in such a way that both the arrows of the components should meet at the arrow of the force. Now when this is 30, this becomes 30. Be careful here. This becomes 30. So therefore this time this force is making an angle of 30 with horizontal. Therefore this is 1500 cos 30 and this is 1500 sin 30. Automatically the other one will be sin 30. So here also this is x-axis, this is y-axis. Next third force is the reaction R. So it is like this. So reaction R is acting like this. This is R. Of course he has given like this. So this is 30 degrees he has given. Therefore this will be 30 degrees. So please check how I am writing. So they are alternate angles. When this is 30 degrees, this becomes 60 degrees. Okay. So see how I have done it. Because this R is at 90 degrees to the plane. So this becomes 60. When this is 60, if you resolve this force into two components, of course horizontal component it will be, I have resolved this force now along this and this direction. Here anyway this will be having only y component, because see this is x, this is y. Only y component will be there. So this R is nothing but the force acting in y direction. So there is no component in x direction here. So R itself, so there is no component in x direction. This is R. Now I will apply the equations of equilibrium. First I will take sigma Fx0. There are three forces here, out of which one force is known. 1500 Newton force is known, whereas P and R are unknowns. Those two forces we have to find out. Now sigma fx0 if I apply, so here please note that I have taken parallel to the plane like this as x-axis. So this side take it as positive. Naturally, the force which is acting in the opposite direction becomes negative. Now take these three forces. First, P cos 30. P cos 30 is acting in the upward direction like this, therefore it is positive. P cos 30 is positive. Then second one, so this one, this is the x direction, so, but it is acting in the downward direction, therefore 1000, so it is negative, minus 1500 cos 30. Then coming to this, there is no x component in this, so therefore it is equal to 0. RHS will be 0. Now, if you simplify this one, you will get P is equal to 1500 newtons. So the value of P, because cos 30 will get cancelled, the value of P is 1500 newton. 1 second. I think this R will be acting perpendicular to it. P will be like this. Okay, at an angle of 30 degrees. P cos 30. Yes, P cos 30 minus 1500 cos 30. Oh, sorry, this is the wrong one. This is wrong. So this, yeah, this is taking an angle 30 degrees to this. 30 degree. So cos 30 will come. This is R. Okay. So I think sigma fx0. Sigma fx0 P cos 30. Is it correct? Otherwise, we will do one thing. This problem we will solve by taking global x and y. Global x and y axis. I think that will be easier. So what I will do here is, I will take now, if you take global x and y, this has x axis, this has y axis. Of course, here what happens, only we have to resolve this R. You need not resolve that P and W because they are acting vertically downwards and this is towards right. So what I will do here is this W will be acting here. Okay. Now here what happens, R if I take like this, you have to resolve this only this R. This is 30 degree. If you resolve this into two mutually perpendicular directions, x and y directions, your x component will be like this, y component will be like this. This is 30. This becomes 30 and this is 30, this becomes 60. So that means this is R cos 60, this is R sin 60. Okay, I think this is better. Instead of taking along the plane and perpendicular to the plane, global x axis, global y axis. Now we will apply that sigma fx0 and sigma fy0. These two equations we will apply. The first equation now becomes sigma fx0 means, so P is of course towards right. So towards right positive if I take, P is positive. Then this doesn't have any horizontal component. This will be minus R cos 60. Yes. P minus R cos 60 is equal to 0. This is one equation which we are going to get. Then the second equation is, or you can simplify this. P is equal to cos 60 is half. Therefore it is 0.5 R. This is one equation. Then sigma fy0 taking upward forces positive. P doesn't have any vertical component. W has got minus 1500 because it is acting downwards. And this R component is plus R sin 60. I think this is best, easy. Is equal to 0. From this you can get R. R is equal to 1500 divided by sin 60, which will be 1500 divided by sin 60. You are going to get 1732 Newton. 1732 Newton. So this is the reaction from the inclined plane to the object. Now you substitute this value in the above equation. So therefore P is equal to 0.5 times R means half of that, which is you will be getting 866 Newton. So this is the force that should be applied on this block to have equilibrium of this block. That is in it. Otherwise, if you don't apply this force P, the tendency of the block is to move down due to its own weight or due to gravity, and equilibrium will not be achieved. So to achieve the equilibrium, to keep the body at rest, we have to apply a force P which is equal to 866 Newton, and the reaction will develop here in this direction, which is equal to 1732 Newton. Now let us see the same problem can be analyzed or solved by using Lami's theorem also. So let us see how it can be analyzed using Lami's theorem. So you should get the same answer whether you use Lami's theorem or whether you use the equilibrium conditions. So since the number of forces acting on the body is only 3 here, we can use Lami's theorem. So that is the basic condition that you should see. If the number of forces exceed 3, then you cannot use Lami's theorem, then you have to use only equilibrium equations. Now only 3 forces are there here, P, W and R. All the 3 are meeting at this G. Now let me solve the same problem by Lami's theorem. So according to Lami's theorem, which I have explained in the last video, F1 by sin alpha will be equal to F2 by sin beta is equal to F3 by sin gamma. That means when a body is in equilibrium under the action of 3 forces, each force is proportional to the sine of the angle between the other 2 forces. Now let us draw the diagram here. G is the point of concurrence. P is acting like this. So you should be very careful when you are trying to draw a diagram. P is acting like this. W is acting like this. It should be correct. Then R is acting like this. So of course this angle he has given. So this angle, this R is making an angle of 60 degrees with the horizontal. So this is what we have got there. Now these 3 forces are acting at G, and the body, the block is in equilibrium under the action of these 3 forces. Now according to this, this W of course is known, 1500 Newton. So we have to find out this P and R. Let us use this Lami's theorem there. I will take F1 as P. This is F1. This is F2. This is F3. You can take like that. R is F3. So F1 is P. So P divided by sine of the angle between the other 2 forces. See, this is P and this is the angle between the other 2 forces, which is 60 plus 90, 150 degrees. So it is P divided by sine 150 degrees is equal to F2 is this force 1500, this weight of the block, divided by sine of the angle between the other 2. So other 2 is this. So this is 30 plus 90, 120. So sine 120, then that should be equal to F3. F3 is R divided by sine gamma. So gamma will be actually 360 minus of this plus this. If you add these two, you will get 270. 360 minus 270 is 90. Angle between these two is 90. Now this is the Lami's equation. Now to find P and R, we have to consider these two first. Then we can take this and this, second and third. Okay. Now considering first and second, P divided by sine 150 is equal to 1500 divided by sine 120. Therefore, P is equal to 1500 into sine 150 by cross multiplication divided by sine 120. So sine 150 is sine 30, sine 160 is sine 60. So of course directly you can get from the calculator 1500 into sine 150 divided by sine 120. So the value becomes 866. So whatever we got there, same value you are getting here, 866 Newton. Now to get the value of R, consider the second and third term. So 1500 divided by sine 120, it should be equal to R divided by sine 90. So we know that sine 90 is 1. The value of sine 90 is 1. Therefore R is equal to 1500 divided by sine 120. So the value will be 1732. So 1732 Newton. So that is the reaction. So whether you use equilibrium equations sigma f0, sigma f0, or whether you use Lami's theorem or Lami's equation, you are going to get the same answer. Of course, depending on the nature of the forces acting on the block, you have to decide whether we can go for local or global x and y axis. Local x and y axis means parallel to the plane and perpendicular to the plane, that is local x and y axis. Global means it is horizontal and vertical. So in this case, of course, since P and W, they are one is horizontal, other is vertical. Only if you resolve this R force, R reaction R along the horizontal and vertical, that is enough. If you take like this as all the three, you have to resolve. So I think this is better. So initially I tried due to that. Then later on I changed. So you should not confuse. So horizontal x, vertical y. So like that we have taken. So we can either analyze using equations of equilibrium. So or you can use Davis theorem. Only thing is you can use Davis theorem only if you have only three forces. Here P, W and R, only three forces are and they are concurrent. Then only you can use Davis theorem. Equilibrium equations you can use for any number of forces. I have tried this problem by both the methods and you can see that we have got the same answer.